Welcome to Curie Electronics. So today we are going to solve one previous year exam question from analog communication based on superposition theorem. So we have completed Thevenin theorem and now we are studying superposition theorem. So what is superposition theorem and how to solve the problems? What are the steps to be followed? We have seen all those. So today this is a question to be solved. Find the current through 6 ohm resistor of the network by using superposition theorem. Also find the power through 6 ohm resistor. This question was asked in 2017 Karnataka. Diploma for diploma students, electronics and communication. So let's solve it. So first what we will do, we will consider one source. First we will consider voltage source and we will replace the current source with its internal resistance, that is the open circuit for current source. So this is 10 ohm, this is 6 ohm, the voltage source the current source we have opened. Now we have to find what is the current flowing through 6 ohm resistor. Let us take it as I1. I1 we have to find. So it is very easy to find. We have to apply the Ohm's law. See, now this is a series circuit. See, this is a series circuit. So we have to apply Ohm's law here. Let's solve. So if you apply I1 equal to what? V upon sum of two resistors, that is 10 plus 6 ohm. So what is the voltage? 30 volt. So 30 volt upon what is the resistance? 16. So if you simplify 30 upon 16, you will get 1.875 amps. Now this is due to voltage source, 30 volt voltage source. Now we have to find, in the second step, we have to find what is the current flowing through the 6 ohm resistor due to the current source. So this is 10 ohm. Here what I have done, we have replaced the voltage source with short circuit, that is its internal resistance. This is 10 ohm, 6 ohm, then we have the current source. Let's take this as I2. Now we have to find I2. I2 is due to this current source. Now we'll apply the current division rule. So I2 equals, we have to take the opposite resistor. That is, I hope all of you know the current division rule. And the sum of the resistance, that is 16 multiplied by total current, that is 10. So this comes to 100 upon 16, which equals, we get 8.125 amps. Now what we have to do, we had two sources independently. By independently considering two sources, we have found the currents I1 and I2. Now we have to take the algebraic sum to find the this is the fourth step. The total current, how current, total current is I equal to I1 plus I2, algebraic sum. And if you see what is the value of I1, I2 we got 8.125 amps. So this is equal to 8.125 amps plus what was I1? I1 equal to 1.875. 1.875, both are in amps. If you add these two, what is the value we get? If we add these two, what we will get? Oh, I made a mistake. It is actually not 8.125, it is 6.25. 6.25. So we have to add plus 6.25. 6.25. If you add these two, we will get 8.125 amps. So by superposition theorem, we have found the current. What current we got? 8.125. Now let's see. We got I equal to 8.125 using the superposition theorem. Let's cross check quickly with a nodal analysis. We have 10 ohm resistor. This is with the nodal analysis. I am checking whether it's right or not. We have the current source. This is 10 amps, 30 volt. This is 6 ohm. Now this voltage I will consider it as V, this node voltage. Quickly I have to apply and find the value. So superposition, we've got the answer as 8.125 amps. Let's verify whether it is correct. We will consider incoming current. This current is incoming here. These two are outgoing. So incoming current I will take it as negative. Then we will apply. If I take it as outgoing current, what I will get? V minus 30 upon 10 ohm plus this. I am not explaining, just verifying whether we are getting the same value. V minus 30 upon 10 plus V upon 6 minus 10 amps equal to 0. Now LCM is 30. So 30, what we get here? V minus 30 upon 10 multiplied by 30 plus V upon 6 multiplied by 30 minus 10 multiplied by 30 equal to 0. Now if we simplify this, what we get? 0 cancels. So 3V minus 90 plus 5V minus 300 equal to 0. So 8V equals to 390. So voltage V, we will get it as 48.75. 390 upon 8, it comes to 48.75 volt. Now what is the current I here? I equal to V upon R, Ohm's law. So 48.75 upon what is the value of our resistor? 6. If you divide, we will get same as 8.125 amps. So whatever we calculated using the superposition theorem is right. I hope these videos are useful to you. If you like the videos, or these lectures, please share with your friends and don't forget to hit the like button. We will solve at least 1 or 2 questions on superposition theorem, then we will move to Norton theorem.